अभी जाऊंगा जाऊंगा आज अब और इसके बाद बस एक ही क्लास होगी। या हेलो एवरीवन। हेलो मोक्षा।
Hello, sir. Good evening, sir.
ओके। गुड इवनिंग एवरीवन। So today is the turn of physics. We'll be continuing with electricity chapter, right? We shall continue with electricity. Just 1 minute. Just starting. Give me 1 minute. Okay. So that's nice. Let's start. Okay. Okay. So I hope the screen is visible to everyone. So in the last class, what all we had done about electric current? See, up to now, you should be able to define with the electric current what you should be aware of. You should be aware of electric charges. You should be aware of electric current. You should be aware of electric potential. You should be aware. So these are the things which I think you should be aware. These are the topics which you should be aware of. Okay. Then electric charges, electric current, electric potential. After this electric potential, you should be aware of one more thing which we discussed in the last class. We discussed about electric circuit. So is everyone clear? Sumukh? Sumukh?
Sir, yes, sir.
Yeah, Sumukh. So what are electric charges? Siddhisri, what are electric charges? Aryan,
Yes, sir.
what is electric current?
Electric current, it is the rate of flow of electric charges, sir. Sir,
Oh. Okay, so can you define electric current?
rate of flow of charges, sir.
Yeah, rate of flow of charges is called as electric current. So see, these are the things which we have done. Up to now, we have done electric charge. So electric charge E is 1.6 times 10 to the power minus 19 Coulomb. The electric current I is given as Q over T, rate of flow of charges. Q is given as Ne, which is a natural number multiple of the charges, of the charge on each electron. So electric current I is given as Q over T. Q is the charge, T is the time. So amount of charge per unit time will be called as electric current. Or you can say rate of flow of charges is the electric current. SI unit of electric current was given as ampere. So SI unit is ampere, which is defined as 1 coulomb per second. So it means if 1 coulomb of charges flow through a wire in 1 second, then we say that the electric current through the wire or electric current is 1 ampere. So 1 coulomb per second. Then we define electric potential. Electric potential we defined as V equals to W over Q. So electric potential, it is defined as the amount of work done in moving a unit positive charge. Amount of work done in moving a unit positive charge. So that amount of work done in moving a unit positive charge is called as electric potential or volts. Here we defined also 1 volt. So 1 volt we define as 1 joule per coulomb. If 1 joule of work is done in moving a charge of 1 coulomb from one point to another, then we say that the electric potential is 1 volt. Arav? Arav,
Yes, sir.
can you define 1 volt?
Sir, 1 volt. Sir, when one. Sir, don't know. Sir,
Try,
amount
try. Hmm.
work done per unit.
Yeah, so what is 1 volt? If 1 joule of work is in moving a charge of 1 coulomb from one point to another, then the potential difference between the points is 1 volt. Okay. So the potential difference between 2 points will be 1 volt if 1 joule of work is done in moving a charge of 1 coulomb from one point to another. So it is like this. So you have here 2 points. Consider here 2 points A and B. And suppose I move a charge of plus Q naught from point A to point B. Then if I am doing 1 joule of work to move 1 coulomb of charges between these 2 points, then the work done will be said to be 1 volt, or the potential difference between the 2 points A and B will be 1. Really? Now today we are going to understand about the Ohm's law. Okay, so we'll see here Ohm's law, and according to the Ohm's law, So we state here about the Ohm's law. Now, Ohm's law, it basically deals with the electric current and potential occurring across the ends of the wire. So according to the Ohm's law, the current flowing through a wire is directly proportional is directly proportional to the potential difference across the ends of the wire. So Siddhisri,
Yes, sir.
Siddhisri, what type of graph do you expect if I plot a graph between potential difference and current? Sudhanshu? Sudhanshu? Dharya.
Yes, sir.
Okay. What will be the shape of the graph if you plot the graph between potential difference and current?
Sir, it will be a slanting line, sir, like
It will be,
slanting line, constantly increasing.
yeah, it will be a constantly increasing a linear graph.
Yes.
So if you plot a graph between V and I, you are most likely to get a straight line. So a graph between V and I being a straight line, it solidifies or it states that it simply means that the potential difference will be directly proportional to the current. So the same is stated by the Ohm's law here. See, according to the Ohm's law, the current flowing through a wire is directly proportional to the potential difference applied across the ends of the wire. So are there also some conditions for this to hold? The answer is yes, we have some conditions. And the condition is that provided physical conditions like temperature and shape of wire are constant. Shape and dimensions of the wire are constant. Not only shape and dimension or remain the same. So shape and dimensions means you are not going to change the length, diameter, anything of the wire. So then we will have the current being proportional to the potential. So now let's try to understand it like this also. So you have a wire here and the ends of the wire, they are connected like this. This is the positive terminal, this being the negative terminal. So we observe or we see here whether the current will flow. So the current will start flowing from the positive terminal towards the negative terminal. Current will start flowing like this. Current will start flowing in this direction. So when the current flow in this direction, then the amount of current that flows through this wire will be directly proportional to the amount of potential difference that is applied. Like you can see that cells have a potential difference which is measured in volts. So you might have heard of cells having the potential difference 1.5 volt, okay, 3 volt, or you can say two cells can be combined to make a potential difference of 3 volt. Got it? Understood this? Understood everyone?
Yes, sir.
So see, cells. Now, the more I apply the potential, the more will be the current flowing through this. So this is just the Ohm's law. Also, you can say V proportional to I. So I'll write it V proportional to I like this. Now, if I convert this proportional to equality, I'll be able to measure V equals to IR. I can write V equals to IR. So definitely I will be, R is the constant of proportionality. R being the constant of proportionality called the resistance of the wire. And 3 to R is the constant of proportionality which we call as resistance of the wire. And put 3 to resistance. Now we'll see what is resistance, how is it measured. So I can write resistance R to be given by V over I. It is the ratio of potential and current. So the ratio of potential and current for a given wire is a constant. SI unit is ohm, written as like this. Ohm. So when can we say that the resistance is 1 ohm? Yes, when can we say that the resistance is 1 ohm? Sudhanshu? Sudhanshu, can you try to define when can we say that the resistance is 1 ohm? Aryan,
Yes, sir.
when can we say that the resistance is 1 ohm?
Sir, resistance is 1 ohm
Yes,
when that when that force opposes.
when there is
When
yeah, very good. You are trying good. You can continue. Continue, please.
sir, when that force opposes it in uh,
Anyone else can try? Moksha, can you try? Moksha,
Yes, sir.
can you try to state when the resistance will be 1 ohm?
No, sir.
See, it's very simple to define it. See, try to define it from the formula. The formula is R equals to V over I. Okay. So if you have a potential difference of 1 volt and the current is 1 ampere, we can say that the resistance will be is 1 ohm. So if I get here potential as 1 volt, current as 1 ampere, then the resistance of the wire would be said to be 1 ohm. Okay. So what is the resistance? We try to define here what is resistance, what is 1 ohm. So first we define the resistance of a substrate or the resistance of a wire. So resistance, it is the opposition to flow of current. Okay. Opposition to flow of current. So resistance, it is the opposition to the flow of current. When the current is flowing, there are some electrons or some other materials which offer opposition to the flow of current. They don't allow the charges or free electrons to move through. So this property of the wire to oppose the motion of electrons is called as resistance. Okay. To measure the resistance, it is measured in ohm. So resistance is measured in ohm. Now let's try to define what is 1 ohm. So 1 ohm when 1 ampere current flow through a wire, when 1 ampere current flow through a wire maintained by a potential difference when 1 ampere current flow through a wire maintained by a potential difference of 1 volt, then how will I- then the potential difference is said to be 1 volt. Okay. So let's try to do a small question over here. Okay. I'm giving you a small question. Please try to solve that question here. So see, the question is, what will be the resistance of a wire what will be the resistance of a wire of if 50 milliampere current flow through it when maintained by a potential difference and maintained by a potential difference of 1.5 volt. So now try to solve this question. Everyone try to solve this question now. What will be the resistance of a wire of if 50 milliampere current flow through it when maintained by a potential difference of 1.5 volt? Okay. Anyone who got the answer? I'm just waiting for the answer from everyone. Sumuk, did you get the answer? Sumuk,
No, sir.
Sudhanshu?
No, sir.
Okay. So where are you stuck? Ayonija?
Sir, I'm
Okay,
solving. Sir, I'm solving it.
okay.
Sir, mega equals to 10 power 4, no, sir.
It's not mega, it's milli.
Acha, milli.
Mega is written with capital M.
Sir, is the resistance 30 ohm?
Uh, yes. So see, this is how you get the answer. So this is, you get here, V equals to IR. So we have to find the resistance. The resistance R will be equal to V over I. So let's try to have in standard units. We are given potential difference as 1.5
Sir, it
volt.
is 30, no, sir.
Yeah, it is 30. So
Okay, sir.
potential difference is 1.5 volt and the current is given as 50 milliampere. So 50 milliampere means we convert this into ampere, which is 50 multiplied 10 to the power minus 3. Milli means 10 to the power minus 3. So we'll write here 10 to the power minus 3. Now keep the values over here. V will be 1.5 divided by 50 multiply 10 to the power minus 3. This will be equal to R. You take this 10 to the power minus 3 in the numerator, it becomes plus 3. So you get 1500 divided by 50 to be equal to the resistance. So
Sir, one
zero,
more zero, sir.
yeah,
One more zero
yes.
also, sir.
No, not 1, but it's 1.5.
Okay, sir.
Okay, so that's why you get 1500. So one of the zero goes with the decimal, so that's 1500. Now you divide by 5, you get here 30 ohm. So the answer is 30 ohm is the resistance of the wire. Got it, everyone? Okay, now let's see. A fuse wire has a power rating of 5 ampere and is operated at 220 volt. Operated at 220 volts. A fuse wire has a power rating of 5 ampere and is operated at 220 volt. Find the minimum resistance that must be used in series. Must be used to avoid fuse failure. Okay. So try this question. Okay, all of you try doing this. Find the amount of resistance that will be there.
Sir, 44 ohms.
Yeah, 44 ohm. 220 divided by 5. That is 44 ohm. So minimum resistance of 44 ohm should be used in series so that there is no failure. Got it? Okay, anyone having any doubt regarding the Ohm's law which we have studied?
No, sir.
Okay, one more question I will be giving you. Just try to do this question. Give me 1 minute. I'm taking out the question here. Just 1 minute. I'm taking out the question. Yes, so see this question. From the observation of Ohm's law, IV graph is drawn here. From that, which points are concluded? So which points are concluded from this? So first point P is given as IV graph is a straight line. The second point is ratio of V and I remains constant every time. The third point is the electric current in a conductor increases in same proportion with increase in voltage. So which statements are true?
Sir,
So
Q is true, sir.
okay, see here the below options are option A is statement P, Q, and are all true. B is statements Q and R are true. C is statement P and R are true. And D is statement P and Q are true.
Sir, option A.
Yeah, it's option A. All are true. IV graph is a straight line. This is true. Ratio of V and I remains constant every time. This is also true. The electric current in a conductor increases in same proportion with the increase in voltage. That is also true. Okay. So see this one. From the observation of Ohm's law. Also, this is the question. Okay. Okay. Bye everyone. We'll see some other questions in next class. Right. Currently we had just this much questions only. Okay. Bye all of you.
Bye, sir.
Thank you, sir.
Bye.